Hello and welcome back to Amomi's Coding Colors Lesson 3. I'm Sean, and in today's lesson we'll shift our focus to coding. Although we have been writing code in the previous lessons, the focus was more on how to set the color of the pixels. But now we'll learn more generic coding skills applicable to all projects. By the end of the lesson, you'll have a solid understanding of variables, increments, if statements, and other coding magic. And we'll put it to use to code beautiful bouncing, color changing light effects. For our hardware setup, the same circuit from lesson 1 and 2 will do you just fine. But if you need a refresher or want to double check the wire diagram, find it on the lesson page. So buckle up, get your coding fingers ready, and let's unleash the full potential of our pixels and create some sophisticated patterns using the power of code. Let's get to it. Like always, you'll need a microcontroller, but this time I'm going to be using the Makery Uno in its 3D printed case. Check this out. This case is 3D printed and is print in place, meaning that you print it, and as soon as you take it off the print bed, it can be folded up and used, no assembly required. Pretty cool. Now it's set up so you can see the light. Plug it into the USB port, and I'm set up and ready to go. Like always, we'll start off using the hardware in the Arduino IDE, then we'll move over to the simulator and see if it works the same on there. Let's get to it. You can start off by downloading the lesson code, and like in the previous examples, we'll start with the CC basic template and we'll build our code from there. All right, now that this is open, we're going to do this lesson a little different. We're just going to save it as lesson 3. And by the end of the lesson, you'll have a long code that does a pretty cool light pattern on your pixels. But we'll start off with just the first part of the code, and we'll slowly be editing and changing the code as we go on. So it'll be almost like a few projects in one, but by the end of it, you'll have the final piece, which will be this color changing, pixel bouncing, cool effect. You'll see. All right, so we've got a file, save as, and make sure you're in the right folder, somewhere that you'll remember where it is. And we'll save it as lesson_3. Okay. As you can see, up the top, it says lesson 3. Of course, you could save it as anything you want. You could call it bouncing lights, whatever, as long as there's no spaces in the file name. So let's start off by just lighting up the first pixel red. Now, I like using the hue, saturation, and vibrance. That's the HSV color codes that we learned in lesson 2. So we'll stick to that, and it's going to be very helpful for our code as we move on. So we might as well start with that. So let's just say we want it to be red. The first pixel would say remember, the first pixel is in position 0, so we'd say LEDs 0 equals color HSV, and then 255. Remember, 255 is red. Saturation 255 and value 255. Now, if I upload this, nothing would happen because I haven't sent the information to the hardware. And remember, we do that with the command fast led dot show. All right. Let's make sure that the correct port is selected. And then we upload the code. All right, and nothing happened. That's because I've got it in the wrong pin. There we go. Moved it over to pin 9 and everything's working nicely. Okay, that's good. Let's carry on. So we can see that this is shining red. Let's just make sure we understand why. So we've got our library, say how many pins. We've got the data pin is number 9. We've got our array, which is called LEDs, and we occupy this array with information, as I'm sure you remember. And it's the information from here that we actually send to the LEDs. After the setup, setting the brightness, all we've done in the loop is we've sent the information to the first pixel, which is in position 0, and we've done the fast LED command. Now check this out. Right now, inside of here, we've got a value 0, but we could replace this with something called a variable. So a variable is a word or a letter or some characters that represent a value. We've got different types of variables that can store different types of information. The first kind of variable we're going to be looking at is the integer variable. An integer variable, as you might have guessed, can store integers, as in full numbers, 1, 2, 3, 4, 5, 6, 7, 8, whatever, but it cannot store numbers with a decimal place. So it couldn't, 1.2 would just be converted into 1, for example. So we're just going to be doing all of our variables up here in the declaration section. These kind of variables are called global variables, but we don't need to worry about that for now. Let's just say for now, every time we create a variable, we do it up in this top section up here. The way we create a variable is first of all say what type it is. Now I've just told you we want to create an integer variable. We use the type int, which stands for integer. We type the name of our variable. Now you can name it anything you like, as long as it doesn't start with a number. There are a few different rules for what you can and can't name your variables, but if you just use a word, you're usually fine. So let's call it pixel, and then you can give it a value, and let's say 0. So basically all this means is that we have a word pixel, but it represents the value 0. Let's see what happens when we upload it. All right, it stays on. So you can see it's working as it did before, but let's try and change it. Let's try and do the other pixel. Let's try and turn this one on, which is position 7. If I change the value up here of the word pixel to a 7 and upload it again, you can see that now the pixel on the other side lights up. So in other words, the value of pixel has changed. You've used the word pixel here, and that's pretty good. Now you might be thinking, what's the point? Let's do an example. Here we've got a delay of half a second, 500 milliseconds, and then we want it to change to a different color, 100 for example. Let's say we wanted to flash it 3 different colors. By the way, Control and T straightens everything up and makes sure everything is formatted nicely. Semicolon. All right, so if I uploaded this code, let's try and guess what would happen. We would have some color show, stay on for 5 seconds, a different color show, stay on for 5 seconds. Now, if we were just using a number, let's say we wanted it to be the second pixel along, which is position 1. So we put this in. See, every time we're doing the same pixel. Let's upload this. Now we should have it changing colors because the hue's different on each one. Now you can see we have this kind of change color LED. Now that's cool and it works just fine. But let's imagine we had this really sophisticated code that was changing many thousands of times, and then we decided we didn't want to flash this pixel, we wanted to flash the next pixel. Using the current method, I would need to go through each one and change its value, right? Now, if I was to use the word pixel every time, all I would need to change is the value of pixel once. Let's change it to 5, for example. And you can see that just by changing it once, it's changing the value at each time we call it. So that's just a quick example of how variables can be useful, but they are useful in a ton of different ways, as you'll see throughout this lesson. And if you keep on learning about code, you'll see that variables are super useful. All right, great. All right, so we finished. So we kind of got an idea of what, of one type of variable, that's the int. So keep that in mind. An integer variable can save integer values to an integer variable. All right, and you can give it some kind of name. If you ever want more information about coding, about different functions, about different variables or anything like that, a great resource is the Arduino.cc website, the official Arduino website. We've dropped a link to the resources area on the lesson page. So if you go to the lesson page, you can see there's a coding reference. And if you go here, you can see we've got all kinds of information. For example, we've just learned about integers. If we go to the variable section and look for int and click on it, You can see we've got all kinds of information about integers here, so you can look at that for your reference. It's a great reference. One thing to keep in mind is the values that you can store in integers. So it's not limitless. You couldn't save the number 1 million, for example. So basically int can store values which are 16-bit or 2-byte values, and they start from negative 32,768 up to 32,767. So you can see you can 0 in the middle, you can go in the negative direction around almost 33,000 and in the positive direction too. If you try to store a number that's greater than 33,000, it would reset back down to the negative value. So you need to keep that in mind if we move on and start doing bigger numbers. Anyway, you can read more about this. All right, we've got this variable here called pixel, and we're going to use that to control which LED we're actually turning on. All right, now we can also use one to replace this. If we're changing color all the time, let's delete all these now. Because we're using CHSV, just by changing this value, we can change the color. So let's use a variable here instead. Let's use hue. So we need to create a variable called hue. So we need to give it a type. This time we're not going to use the type int. We're going to use the type byte, B-Y-T-E. So byte, hue. Let's give it a value of 255, which you know is red. Let's upload this. Let's see if it shines red, see if it's working. Okay, great. So that's working nicely. Let's take a look at byte. Let's go back to the Arduino reference page and let's look at the word byte and see why this is more useful for hue rather than using int. Because I could use an int. I could have made a variable int type and I could have saved the number 255. So let's see why I've chosen to use byte instead of int. Now you can see a byte stores an 8-bit unsigned number. Unsigned means no negative values, from 0 to 255. Now, if you remember from our previous lessons, to control the hue, we need to give it a value from 0 to 255. So that's perfect. Because a byte can only store values from 0 to 255, that means we could never put a value that's incorrect if we are using a byte variable. For example, if I said that my byte was equal to 300, it would go past 255 limit and reset to 0 and go up the remaining 45 places. So the value would be 45, if you get what I mean. It kind of resets at 255 and goes back to 0. So let's say that it starts at 0. Let's look at some operators. Now, an operator is a symbol like an equal sign or a plus sign that does a job, that changes a variable or compares variables. There are a ton of different operators that you can also see from the Arduino reference page. So if we go back to language, you can see there's all different kind of operators down here. Compound operators, Boolean operators, many to learn. And the first one that we're going to be using is the compound operator, which is increment. And you can see that plus plus is an increment, meaning +1 basically. So let's try and use that one and see if we can create a kind of rainbow cycling effect on this pixel here. So if we say that we have a variable called hue with a value of 0 and we upload it, we know what that'll look like. We know that 0 is red. 0 and 255 are both red. Let's say we do a much quicker delay, just 10 milliseconds. And then we say that at the end of each iteration, the end of each loop, hue increments by 1. So hue starts at 0, we wait. Oh, that's meant to say 10. Hue starts at 0, we wait, then it loops around. When it comes to this line, hue is now 1, then it'll be 2, then 3, then 4, and it'll keep going up until finally it hits 255. What happens when we go over 255? It will reset back to 0. So we'll be cycling around this. And as you may have guessed, this means we'll be cycling through all of the different colors and we'll get some kind of rainbow effect on this single pixel. Let's try it out. You see it's fading through all the colors. Beautiful. I'm not sure how well that's showing up on the camera. So I'll try putting some paper over the top and see if that makes it more clear. Excellent. So you can see that with this simple code, just a few lines of code, just by using the correct variables and the correct operators, we've created a really cool looking pattern. And we're off to a good start. All right, I say that we're going to introduce our first operator, but we have been using them as well. For example, this one, we've got the equal sign. Now, as you're going to learn soon, that there is another operator, which is double equals. And often people get confused between the difference between a single equals and a double equals. But let's just say for now, the one that you've used is when you are assigning a value. So if you're saying, hey, this thing here has this value, means you are giving it a value. You're using this equals to say this is what its value is. For example, we've used it here. We're saying hue has this value. We're saying pixel has this value. Every time it's a single equals, we are giving a value to something. Just keep that in mind. All right, let's move on. Now we're going to try and make the active pixel, we'll call it the active pixel, the one that's shining. We're going to make it start at 0 and then run down to the last one, which is position 7. So let's try and do that. So we can start pixel at 0 and we can change the delay. We'll take this away now for this part of the code. Let's change the delay to something a bit more suitable, like 50 milliseconds. So every 50 milliseconds, we're going to change to the next pixel. And let's see how this one looks. If we say pixel plus plus. Now, before I upload a code, I always like to figure out what's going to happen before I upload it. Then if it happens exactly the way I thought it would, then I know I'm doing something right. If it's not quite the same, I'll always go back and try and figure out why it's not working. And it's a good way to learn and improve. All right, so let's have a look. So we know that pixel currently has a value of 0. So that means, and hue has a value of 0. So that should be shining red. So we know that the very first pixel in position 0 should shine red and it should show. We should wait for 50 milliseconds and then pixel plus plus means that now pixel will have a value of 1. So the next pixel should turn on, then the one after and the one after. So after 50 times 8 milliseconds, all of the pixels should be on. Now we have never turned a pixel off, so it won't be one at a time like this. It should be all of them lighting up. So we'll start with an empty strip and then all of the strips should be red by the end. Let's see if that's exactly what happens. You can see it fills up. It's quite satisfying. All right, so let's move on. What we want to do now is create a kind of effect that bounces from one side to another. So let's not worry about colors for now. Let's just try and get one pixel bouncing from one side to another. Now, I don't want it to all turn on for now. I want it to turn on and then turn off. So perhaps if I want that to happen, I copy this. And then I change the pixel after it's been shown for a second. And before we've changed its value, I say that I change the saturation and brightness down to 0. And that should turn it off. So let's see if that works. So basically we'll turn on pixel 0 and show it glowing red. We'll turn it off and then instantly increment to 1 and then we'll show pixel 1. So basically we should just have one light flashing. Let's see if that works. Perfect. Did you see it flash across? I'll reset. By the way, this is the reset button on the microcontroller. Reset and it starts again. So it flashed across. All right, so now that we've got the lights turning on from left to right, we're going to start trying to transition to bouncing a single LED from left to right. The first thing we'll look at is a different type of variable. So far we've looked at the integer type, which can store an integer value from negative 32,000 and something up to positive 32,000 and something. And we've looked at byte, which is very similar to the int apart from the range of values that you can store. The byte type variable can store a value from 0 to 255. And we already discussed why that is useful for using it to control the hue of our colors. Excellent. Now the third type of variable we're going to look at is BOOL, bool, which is short for Boolean. Now a Boolean variable can only store two values, a 0 or a 1. Sometimes you can also refer to it as true or false, or high or low, but basically it is one or the other. It cannot have a range of values. It's yes or no. That's what it stores. So if we have a Boolean called direction, or we'll just call it dir, short for direction, we're going to use this Boolean to determine which way the lights are bouncing. So we could say, for example, that true means bouncing this way and false means this way, or 0 means bouncing this way and 1 means bouncing this way. We only have two directions to choose from. Therefore, the Boolean variable is perfect for our use case. So let's say we've got a direction equals true. We'll make a comment. True equals 1. So we could put the number 1 there and it would be the same as writing true, and false equals 0. So if you could use either of these, the word false or the value 0, they are interchangeable. The word true and the value 1 is also interchangeable. We'll stick with writing true or false. All right, next up, let's learn about if statements. It's just like an if statement in regular language when we're talking. For example, you have if some condition, something else happens. I'm holding the remote. If I open my hand, the remote falls. So if something happens, something else will happen. So we've got some kind of condition that must happen, and then if this condition does happen, or if this condition is true, something happens, right? It causes something else to happen. So let's just say if, now we've got our Boolean variable, which we named dir for direction. The word doesn't really matter for now, is equal to true. So this is our condition. If dir is equal to true, and then we can put something is going to happen if this statement is correct. So we need to use the curly brackets like this. So if we hit curly bracket once, you'll automatically get the second bracket, press return, and something happens. So the code for what happens if this statement is true will go inside of here. Let's try this out. I'll cut this and I'll put it in there. If I upload this code, do you think it will shine red? Well, probably right, because look, dir does equal true. So if dir is equal to true, do this code. Okay, our pixel shines red. If I change up here, I change it to false. Let's see what happens. If I unplug it and plug it back in, you can see it is off. All right, so you might have noticed that this has double equals, whereas every other time we've used equals is single equals. So let's see the difference. It's good to look at this and compare it to this, right? In this case, I'm telling the compiler dir equals false. I'm saying this is what it equals. I'm assigning a value of 0 to dir. This one is not assigning a value, it's checking a value. It's asking the question. So the double equals is asking the question, does dir equal true? Is it equal to true? The answer to this question is no, because it actually equals false. Therefore, we don't do what's inside of these brackets. You see, when I upload this code, the light will not turn on. Code uploaded, done compiling, done uploading, no light. I change this value back to true. And upload it. And the light turns back on. Now let's demonstrate this a little further. If our condition is a Boolean condition, as in it can only answer yes or no, there's only two options. A good thing that we can do afterwards is put else. So if this is not true, there's something else that must be true. So let's say we want it to be a different color. Let's say we change this to 100 just to demonstrate it. So basically we're saying if direction equals true, if dir is equal to true, shine this color. Else, meaning if it's not true, if it's the other option, if it's false, do this color. So we've got two different colors. Let's just actually write the colors this time. Let's say 255 and 100. So you've got two different colors. If dir is true, it'll shine this one. Else, otherwise, if it's false, we'll do this one. So let's do that. Right now, is it true? Yes, it's true. So we should shine this color, which is red. All right, let's change this to false. See what happens. Oops. False. Now what should happen? It's going to check if this is true. This question is not true. Does dir equal true? No, it does not. So it's going to do this one. It should shine whatever color 100 is. And wonderful. The color has changed. So that's pretty cool. Let's try doing something else. We've already looked at some operators. It's a pretty useful one we can use with our Boolean variable. So if I say dir equals, so we're assigning a value, equals exclamation mark dir, what it's going to do is reverse its value. So let's say right now it equals false, which it does up here. So that's what we set it as. And when we first declared this variable, we said it's equal to false. And then it says equals exclamation mark dir. Now exclamation mark in C++ means not. So equals not dir. So if dir equals not dir, basically says if this equals not false, that's what it kind of means. Equals not itself, like if false equals not false, it means it equals true. So in other words, it flips its value. So if that's confusing, just know that if you put a Boolean variable at either side of equals not, it's going to flip it. So if it's false, it will now equal true after this line of code. If it's true, it will now equal false. Let's delay this to, let's say, half a second. And now what should happen is this dir keeps changing its value from true to false, true to false, true to false. And this if else statement, if else, should be either coloring it red or green, depending on whether or not dir is true or false. So we should have this changing color kind of effect. Let's check it out. Upload the code. And we are jumping from red to green. Excellent. Let's move along and let's see if we can use everything that we've learned to create a bouncing light effect. Now, there will be some other operators and stuff that we need to add to the code, but most of it should be making sense by now. Okay, I'm going to basically delete everything and we'll just write everything fresh. We'll change this back to hue. We're going to send the correct information that we want to our LEDs array. Then we're going to spend the rest of the code kind of changing the information around. So it changes each iteration. That's how we get this animated effect. So we're going to say if dir, if direction is equal to true, we'll say that we're going in the positive direction. We care about changing which pixel is on, so that the variable pixel needs to be incremented each time around the loop. We need to increment this way when it's in the positive direction, but when dir, which stands for direction, becomes false, we're going to change it to go in -1 rather than +1, so go in the other direction. So it'll be positive, negative, like this. So the way we do that is by using pixel ++. That means add 1 each iteration. Else, curly bracket, next line. Else, you probably guessed it, if we're going in the positive direction, we use positive. If we're going in the negative directions, negative. So basically by changing dir, we're going to change the direction of this bouncing pixel. Excellent. Let me just upload this code for now. Let's say we delay 50 milliseconds and upload the code. And let's see what happens right now. So right now we get nothing. Now let's, like I say, if things don't go out of the plan, we always need to try and understand why. Don't just go ahead with the code. Try to understand why. Now if we think about it, pixel starts at 0. Right now we're saying direction is false. What happens in the case that direction is false? So if direction is true, we do the positive direction. If it's false, we go in the negative direction. So if it's 0, we're saying pixel 0, and then we're going in the negative direction. It's going to be pixel -1, -2, -3. It doesn't really work. It's not, it doesn't make sense. If we change it to true, if we change dir to true, we might fix this problem. So if we say true, see what happens. So you can see it shines across and all of them are lit up. All right, let's look at this setup. So now let's say we turn on the LED, whatever the current pixel is. We turn it on. We give it the value of whatever the hue is right now, which is red. And we show it, then we wait, and then we change it, whatever current pixel is, to 0. And then we mean move on to the next one, and the next pixel gets colored on, and then we change the information to black. And so on. We should have one pixel moving down. There we go. So let me try and make it clear what's happening. So let's say pixel 0 right now is red, and we show it. Then we wait 50 milliseconds, and then we change that pixel. We change the information in the array to black, but we don't hit show. We just change the information to black, and then we say pixel++. So now pixel equals 1, pixel 1, we color it and we show. So what are we showing? We're showing this previous time when pixel 0 was turned to black, and we're showing now that pixel 1 is turned to red. After it shows for 50 milliseconds, we say pixel 1 now equals black, and then we change pixel to having a value of 2. We put pixel 2 now equals red, and we show it. We know that pixel 1 from this previous iteration is changed to black, and so on. And this works great to flash in one direction. There you go. And you may notice that after I talk for a while, it flashes again. That's because the variable is resetting once it hits its limit, but don't worry about that. All right, great. So now we need to worry about it bouncing back in the other direction. So when should that happen? When should I change direction from true, which means that way, to false, which means moving back this way? If the pixel gets to the end, right? What's the end? The end is 7, right? Because we've got 0, 1, 2, 3, 4, 5, 6, 7. So the 8th pixel is 7. So once we reach pixel 7, we want to bounce back and go in the other direction. So if pixel is equal to 7, then dir, remember our trick from before, equals not dir. So in other words, change the value from true to false or false to true. Let's see what happens now. So now we go there and we bounce back. And it is kind of bouncing, but you can see there's a delay there. It's not actually working properly. It's actually to do with things resetting. That's actually making it go back in this direction. So we could leave it like that and it looks all right. But we also want it to change direction as soon as it gets to pixel 0. So we can use comparator OR. You have to hit shift and backslash. And you get this. You get these two vertical lines. Now these two vertical lines mean OR. You can go back to the Arduino IDE if you want, and operators. And you've got the Boolean operators here, and you've got here logical OR. You can click on this and learn more about it if you like. But basically, this means if this or this, right? So in our code here, we can say if this is true, if this question is correct, pixel, does it equal 7? If the answer is yes, do this. Or if pixel equals 0, So if this is true, or if this is true, do this. Otherwise, don't do anything. Let's upload it and see how this works. All right, let's say we wanted to change hues. Let's say that each time it gets there, we want it to go a little bit further around the hue cycle. So every time it changes direction, this would be a good time to change the value of hue. So let's say we said hue. If we just said plus plus, it means it would go up one step each time, and that might just be a very gradual change in color. If we wanted to change color in bigger steps, we could say something like plus equals and then put some value. So let's say we put 30. So if I say hue plus equals 30, it means whatever hue is currently equals itself plus this value. So let's say hue right now equals 0. Hue plus equals 30. Now hue will equal, after this line of code, hue will equal 30. The next time around, it will be 30 plus 30. So it will equal 60, then 90, and so on, until finally it hits 255, which it will reset back to 0. Let's see how this looks. So you can see that each time it hits the extreme, the color changes. It's bouncing forwards and backwards and the color is changing. Now that looks pretty cool and we could call that finished. That one's nice. But let's see what it looks like if we also comment out this one. This is the line that turns the pixels black. With this effect, we get the whole thing coloring in, changing color, and then coloring back out and going backwards and forwards. Now I like this effect more. Looks super cool. Let's put a piece of paper over the top and diffuse it so you can see it a bit better. You can see that's quite a nice effect. Beautiful. Okay, now that was a lot to take in. If you understood 50% of that on your first watch, well done. It's not easy, but it's one of them things that the more you do it, the more it makes sense. And when it does make sense, it just seems very easy. And you'll probably look back to how you felt now if you are struggling and think, oh, what was so difficult about it? But everyone struggles in the beginning. What I advise that you do is just go through this lesson, and each step, make sure that you understand what's happening with your hardware or your simulator, and just keep running it and running it until you understand it. Then move on to the next stop, move on to the next stop, until finally you understand this full code and understand exactly why these words or why this code is making this happen with your hardware. All right, last step. Let's move on. Copy all of this over to the simulator and see if it works just the same. So I'm going to hit all and copy. I'll go to the lesson page, walk we, and take us to here. All and paste. Upload it and see if it works. All right, you can see that it doesn't look very bright. And one thing I forgot to do is change the brightness. We learned last time that 50 is not very bright on the simulator. So let's just turn it to full brightness, 255. Upload it again, see how that looks. And you can see that the colors are changing. It's bouncing back and forth. It's only doing half of them because we've got 8 pixels. Now, we could make some changes to do the full loop if you wanted. So we'd need to change num LEDs to 16. And another place we would need to change is this one, which tells it when to change direction. And we could put 15. Now we could have used the variable num LEDs -1, which would have had our 15, and it would have changed automatically had we've done that. But we don't need to overcomplicate things at this step. Let's see how this one looks. Beautiful. Look at it go. All right, guys, thank you very much for joining me on lesson 3. I'll see you in the final lesson.